Thousands of years ago, under the exact same stars we see tonight, ancient Indian astronomers looked up and calculated the speed of light. They clocked it at roughly 186,000 miles per second, arriving at a number with less than a 1% margin of error. Today, we are going to test that calculation. We are embarking on an impossible journey to the absolute edge of existence, traveling at the universe's ultimate speed limit, exactly 300,000 kilometers per second. Launch. Before you can even blink, we've arrived at our first milestone. In just 1.5 seconds, we passed the moon. Sitting down there in the freezing dark of the lunar South Pole is the gold-wrapped Chandrayaan-3 lander, one of our most recent footholds in space. But even our greatest achievements are already shrinking into the void behind us. At this speed, the local yardstick of human history is entirely inadequate. Just 4 minutes later, Mars rushes up to meet us. Below is Olympus Mons, a volcano 3 times the height of Everest, and orbiting high above that is India's Mangalyaan spacecraft, a feat of engineering that reached the red planet on its very first attempt. "8 minutes and 20 seconds into our flight, we blow past the sun. Every ounce of energy that has ever sustained life on Earth is generated in that massive furnace. 8 minutes into the journey, the sun dominates the view. It burns through 600 million tons of hydrogen every second, and now it is just a receding point of light in our rearview mirror. This map shows the true scale of our inner solar system. A pulse of light leaving the sun takes 8 minutes and 20 seconds to reach Earth, and 12 minutes and 40 seconds to hit Mars. In less than 15 minutes of light speed travel, humanity's entire physical domain, every mountain we've climbed, every planet we've touched, is reduced to a microscopic speck. At 43 minutes, we arrive at Jupiter. Right ahead is the Great Red Spot. This violent cyclone has raged for over 3 centuries. It's wide enough to swallow 3 Earths, crackling with lightning 1,000 times more powerful than ours. 1 hour and 20 minutes in, we slice through Saturn's rings. From Earth, they look like solid, smooth silk. Up close, you see they are countless individual shards of ice and rock, from sand grains to entire mountains, locked in perfect orbital harmony. By the 4-hour mark, the sun is nothing more than a bright star. We are at Neptune, where the atmosphere is choked by supersonic storms, and the crushing pressure forces carbon atoms to crystallize. It literally rains diamonds here. The outer solar system is defined by these hostile physical realities, where diamonds rain from the sky and mountain-sized rocks dance in orbit. We can see them, but we can never touch them. The sunlight dies away as we pierce the Kuiper Belt and the Oort cloud. This vast spherical shell of icy debris marks the true edge of our solar system and the beginning of interstellar space. At 22 hours, we encounter a piece of home, Voyager 1. Launched in 1977, it is humanity's most distant physical ambassador. Bolted to its side is a golden record, a copper disc containing the sounds of Earth, all of our music, greetings in 55 languages, a message in a bottle, cast into the dark. After 4 years of unbroken darkness, we reach Proxima Centauri, our closest stellar neighbor. Orbiting it is a rocky world locked in a harsh twilight zone between burning radiation and frozen night. We cross past the brilliant Sirius star system. Looking back, our sun fades away, entirely indistinguishable from billions of other background stars. Next is Sirius and its white dwarf companion, a collapsed stellar core so dense that a single teaspoon of its matter weighs as much as an entire mountain. The center of the Crab Nebula, we find a pulsar. This city-sized remnant of a massive star spins dozens of times every second, lashing the vacuum with energetic pulses. This diagram shows a much harder boundary. At 125 years of travel, we hit the radiosphere. This is the absolute physical limit of every song, television broadcast, and radar ping humanity has ever transmitted. Once we cross this line, we enter true cosmic silence. If there is anyone out there beyond this boundary, they have never heard of Earth. To the wider universe, we do not exist. 7,000 years pass. Towering out of the dark, we find the pillars of creation. These clouds of interstellar gas stretch light years across. Inside, gravity crushes material together until it ignites, forging brand new suns. At 26,000 years, the star field grows dangerously thick. We are diving into the center of the Milky Way, passing Sagittarius A star. It is a supermassive black hole weighing 4 million times more than our Sun, dragging a blazing disk of ultra-hot matter around its event horizon. We keep going. At 2.5 million years, we reach the Andromeda Galaxy. It is a swirling vortex of 1 trillion stars, currently on a collision course with our own Milky Way. As millions of years blur into billions, individual galaxies vanish. The universe reveals its underlying structure, the cosmic web. Billions of galaxies are strung together by threads of gas and dark matter, separated by vast empty voids. Finally, at 13.8 billion years, we hit a wall. This map shows the cosmic microwave background. It is the absolute oldest light in existence, the literal afterglow of the Big Bang itself. Before this moment, the universe was so hot and dense that light couldn't even travel. This is the absolute physical edge of the observable universe. We cannot see anything beyond this barrier. Every light year we gain, the space ahead of us expands even faster. Even at the speed of light, the universe is growing faster than we can cross it. But there is a catch to this entire journey. According to Albert Einstein's theory of relativity, traveling at the speed of light warps the very fabric of reality. This diagram illustrates our final hurdle. Space stretched while we traveled, growing the total distance to the horizon from 13.8 billion light-years to 46 billion. This chart maps the gap between that ancient light and its source galaxies. Because the universe grew, those galaxies are now 46 billion light-years away. As space accelerates, they recede faster than we can chase. We can never close the distance. This is a hard physical limit for human exploration. It is a boundary we can see but never cross, the exact place where our physics ends and impenetrable mystery begins. Virgo cluster, 50 million light-years away. The light hitting our viewports right now left these stars when dinosaurs were still walking the Earth. This animated map tracks the Great Attractor. It is a gravitational anomaly that pulls hundreds of thousands of galaxies toward a single point, like a cosmic river. Then the clusters vanish. We enter the Boötes void, a region of space 330 million light-years wide. There are no stars here. This map tracks the cosmic web, billions of galaxies strung along filaments of dark matter, separated by massive voids. Inside this structure, individual galaxies function as tiny drops of dew clinging to the dark matter threads. On this scale, entire galaxies, trillions of stars, are just minor structural components, dwarfing any human concept of importance. Galaxies have merged and the stars of our youth have died, leaving us permanently separated from the timeline of our birth. When we look back at the scale of these ancient galaxies, we are reminded of how small our perspective remains. If we turn the ship around now to head back, Earth is gone. The sun burned through its fuel billions of years ago. Everyone you ever knew and every monument has crumbled into cosmic dust. In our attempt to conquer the physical space of the universe, we trapped ourselves. Moving at the ultimate speed limit, we've taken a one-way trip to the end of time. Physically, we are nothing. We are fragile creatures living on a speck of rock, orbiting an entirely ordinary star, surrounded by an indifferent void. Yet those ancient astronomers didn't have telescopes or satellites. They mapped the mechanics of the cosmos using only mathematics and an insatiable curiosity. We can never physically survive a trip to the edge of the universe, but we are the only creatures we know of who have looked into that dark and successfully calculated exactly how far it goes. We are completely alone in an empty universe. We successfully outran time to chart the filaments and voids of the cosmic web.
We are small, but our curiosity allows us to measure the end of time.